So today's lesson is all about double angle formulas. So if you notice on your foldable, every single one of these starts with 2 times theta, which if you multiply something by 2, that's the same as doubling. So these are all double angle formulas. And basically what they allow you to do is, say you have a big angle, you can break it into break that big angle in half, and whatever half of that angle is, you can use this formula to solve. You'll see what that means in just a moment. But something that I want you to notice here is that cosine actually has 3 double angle formulas. This was the initial one, but then these two can be created from the first using Pythagorean identities. So I just want you to realize that these are all related. We're not going to have to memorize them, so you don't really need to know how to manipulate in between the 3 of them, but just know that they are very closely related, and this one's useful if all you want to do is sine, all you want to do is cosine, or if you want to do both. So it just depends, especially when you're doing proofs, which one you want to use. So let's go ahead and do an example or problem or two. These are going to have very similar flavor to the lesson we had yesterday. So if you liked yesterday's lesson, you'll probably like today's as well. So the first one that I want to do is find the exact value of 2 times tangent of 15 degrees all over 1 minus tangent of 15 degrees. So looking at that, that might seem really complicated because we don't know how to find tangent of 15 degrees. That's not one of our special angles, so we definitely can't find an exact value because the calculator is just going to give us an approximation. However, now that we have these formulas, if you look over at your foldable, it should be really obvious which one of these it fits. Okay, if you look at that double angle formula, it's the right hand side here. It's exactly the same except your theta is filled in. What is our theta in this example? Hopefully you're like, well, it's 15. So over here I'm just going to highlight that. So the 15 is my theta. If 15 is my theta, then I can actually work this formula in reverse. I can say that 2 tangent of 15 degrees over 1 minus tangent of 15 degrees is equal to, working in reverse, tangent of 2 times, and my theta was 15. So you see there, all I did was work the formula in the opposite direction of what seems natural. So we're bringing things together instead of making it more complicated. And we know that tangent of 2 times 15 is the same as tangent of 30 degrees. And we know how to find 30 degrees. We have a special triangle for it. Right? And I always have to draw mine, so don't feel bad if you have to draw yours as well. So here we go. That's my special triangle. And tangent of 30 is 1 over the square root of 3. I know that I'm going to have to rationalize, so that equals the square root of 3 over 3. So all of this right here equals this right here. And that's my final answer. That's the exact answer. And if you type this in a calculator, and you type this in a calculator, they would be the same decimal. Pretty cool. So let's find another one. That was working the formula in reverse. Let's work the formula in left to right. So we're going to find the exact value of sine of 120 degrees. So you can see that's a large angle. We actually could use a reference angle on this, but we can also use one of our formulas. Okay, so you could use a reference angle. What I mean by that is you could draw it in the second quadrant and blah, 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 and do all that. But that's not what this lesson is about. This lesson is about breaking this in half, like this formula over here has. So 120 degrees, how can we rewrite that as 2 times something? Well, let's go over here, write it down. So how can we rewrite sine of 120 as sine of 2 times something? Well, we can make that something 60 degrees. So these two are equal. And now we've got this set up so that it looks like our double angle formula. Now we know that this 60 degrees is our theta. So now we can look over at that formula and rewrite the formula with theta plugged in. So we've got 2 times sine of 60 degrees times cosine of 60 degrees. And now we can solve this. Okay, because remember, once you have an angle in here, sine of 60 degrees is actually a number, and so is cosine of 60. And they're both things we can find using our special triangle. I'm just going to use the one I drew up here. So sine of 60 is the square root of 3 over 2, and cosine of 60 is 1/2. So since we're multiplying fractions here, I'm going to write my big 2 over 1. These 2's cancel, and my final answer is going to be the square root of 3 over 2. So there you can see it's a multi-step process, but once you practice it a few times, it'll really start to become second nature. You see this big angle. You realize that if we broke it in half, we could find something about 60 degrees. So we use the double angle formula, and then whatever we find for theta, we plug in for theta in the actual formula, going left to right, and then we evaluate it and get our final answer. Okay, so these are both evaluating, finding an exact value, but there is another type of question here, and there are verifying identities as well, but I'm not going to do one in this video. So in the next video, I'll do the third type of question.